Hi everyone, welcome to this Jupyter and Education short talk at JupyterCon 2020, entitled From Zero to Hero, Using Jupyter Notebooks to Put Scientific Computing on the Map at Girls' Schools. So my name is Chiin. I'll introduce myself in a moment, but let's first establish the crux of this talk up front. So looking at the latest hype cycle on the left-hand side, which is an imperfect but useful litmus test of the global innovation frontier, you can see that scientific computing is central to most of these emerging technologies. However, if you compare and contrast with the right-hand side, which reflects what typically constitutes computing education for school-aged kids, you can see that this landscape is dominated by physical computing, visual programming, game development, GUI programming, and things like VB.NET are still actually very popular in a lot of schools today. So where is the scientific computing for school-age kids? To me, kids are missing out on a variety of empowering outcomes. So whether in terms of being prepared for entering the future workforce, having tech literacy to navigate an AI-driven society, or just mental health benefits of a fun, stimulating hobby. I also want to quickly recognize, as a sort of side point, that digital and other kind of poverty is actually more commonplace, and the reality is that the majority of kids in the world don't actually have access to any computing education, let alone scientific computing education. But that's a much bigger topic for a different talk. So, for the purposes of our privileged circumstances, where computing education is viable, this talk fundamentally shows that Jupyter Notebooks can be an effective gateway for schools and school-aged children to discover and benefit from scientific computing. I'll now quickly introduce myself to put this talk into context. So I'm a tech entrepreneur with 13 years experience innovating using data science technologies. Coming from a social science background, I've taken quite a concerted effort to upskill myself, particularly computationally, and developed a parallel passion to help others upskill. As you can see from this photo of me running an R meetup that I founded in London, which then became global. So I later turned this passion for outreach into a full-time job, which is what I do currently. So I founded an edtech startup with a strong social mission of democratizing opportunities for school-aged children to develop modern computing literacy. The school-aged kids I currently specialize in working with are students in secondary girls' schools around London. So if you're familiar with Harry Potter, then Hermione in her first few years of Hogwarts is not a bad proxy, actually. What I actually do at these kinds of schools is pioneer new scientific computing education initiatives. So, it could be things from data science experiences to homework to learning apps. But whatever it is, they're all critically enabled by Jupyter Notebook technologies. But why is scientific computing education missing in the first place? And why the need for a gateway in the form of Jupyter? From my perspective, the simple answer is that often scientific computing education cons outweigh the pros in this domain. So I've distilled all of my experiences and observations of the UK education system into this visualization, which shows some of the reasons which I think are quite common for scientific computing's overall zero status. However, my experience shows that Jupyter Notebooks can change this balance through the aggregate effect of certain features of the technology. So looking at the first notebook feature listed, which is open source software, on the right-hand side, you can see that Jupyter makes scientific computing more affordable because the school or the student users don't have to buy any proprietary tech or licenses. So that starts to swing the balance. Taking the next feature, prototyping and exploration, Jupyter basically showcases scientific computing for experimentation, which is something I found is actually extremely popular with the kids I work with, even if the experience is only digital and doesn't have any sort of physical interaction. And so actually this challenges some very popular computing pedagogies and starts to develop new pedagogies which recognize scientific computing's value. So another feature of Jupyter notebooks are the ability to accommodate diverse use cases. So this really demonstrates scientific computing's versatility because it means that this technology can support cross-curricular exploration at schools. So, whether that's computational economics or code art. A major advantage of Jupyter and scientific computing is that they are de facto tools for many tech professionals. For many students and educators, the fact that they are actually using the same technologies as AI researchers or data scientists at NASA makes a tangible difference to their scientific computing education experience. A final key feature of Jupyter notebooks is the fact that Jupyter's high reproducibility boosts the reusability of scientific computing efforts. And in an educational setting where kids, will need to keep practicing the same code multiple times before they get it, the ease of reusing and sharing scientific computing outputs is a massive bonus for both students and educators. So you can see in this model how Jupyter enables scientific computing pros to outweigh the cons through the aggregate effect of certain key features. And now scientific computing education has hero status. Okay, so that's how the model works. And let's put this new scientific computing hero status into some real world context. So here are examples of the scientific computing and data science education that I've successfully democratized through my startup using Jupyter notebooks. And of course, more importantly, here are example resulting impacts on students. So, for example, girls want to continue the scientific computing school activity in their own time. They ask to replicate the Jupyter notebook setup at home. The girls are disappointed at the end of the scientific computing activity and ask for more. And this one is probably the most important for me, actually, is that girls struggling in science subjects, traditional science subjects, for example, discover they actually have an intrinsic ability in scientific computing, which brings them new enjoyment and confidence. And there are resulting impacts not just on students, but also on educators. So you can see on the right-hand side some really great responses by key stakeholders that I've worked with. And then on the left-hand side, here's an example of some sustainable impact of the initial scientific computing education that I brought into the school. And you can see in the text that the school is choosing to build on and, in fact, scale the kind of learning that I delivered, which is absolutely brilliant. So, some great examples of how scientific computing education becomes firmly on the map. In conclusion, grassroots experience at London girls' schools shows Jupyter notebooks can uniquely facilitate discovery and adoption of scientific computing and data science education, which can result in empowering outcomes for students and educators. So let's create more opportunities for kids to access Jupyter-enabled tech education and democratize the benefits of modern computing literacy as widely as possible. So thank you for listening.